again to answer a fun question using the quadratic formula. Find the local minimum or maximum of a function. So here is the equation that was given. So g of x equals 2x squared plus 8x plus 5. So if you have the capability of graphing that, there are a bunch of online calculators you can use. Desmos is a very famous one, or others, or even with your graphing calculator, if you happen to have that. I recommend first try to plot, and so that's what I did here. So I have my x variable here and my g of x on the y-axis. So when I plot this, here's what I get. And so just by looking at this, I would say, it looks like there's a minimum, right around here. And if I look, I'd say, wow, that minimum looks like it's about -3. So if I could graph it, that might be a quick and easy way. But is it really -3? Is it a little off? I mean, so there's more of a mathematical way to do it. So one approach may be, oh, you see the word quadratic and it looks like a quadratic. You could use the quadratic formula. However, what the quadratic formula typically does is it sets this expression equal to 0. And what it does is it finds the values where the function crosses 0 here. So if you did the quadratic formula, you'd get this point and this point. So that's not what you're looking for because clearly that's not a minimum. But instead, there is a technique in algebra called completing the square. So if you remember that, that's what I'm going to show you in the next few steps, and we can use that to get the solution here. So the first thing I did was take this g of x, and I factored 2 out from the 2x terms. So just prove to yourselves that if I distribute this 2x squared, and 2 times 4x is 8x, and then I have the 5. So all I did was factor out a 2 from both the x squared and the 4x terms. Now what I'm going to do is actually complete the square. That wasn't complete the square, that was just a simplification. So now completing the square. What do? We take this value right here next to the x term, divide it by 2. What is half of that? That's 2. Then what do? We square it. So half of 4 is 2, square that, and we get 4. Now, we can't just add 4 randomly to an equation. So we have to do something with this 5. And so if we add 4, we have to now subtract that equivalent. But notice what it is. Relative to this equation, if I take this 2 times 4, I'm really adding 8. So here, what I have to do to modify this equation is take my 5, and I need to subtract off that 8. Very common error that I see with completing the square is they might just bring this 4 here and not take the 2. So that keep an eye on that, okay? So now we just need to simplify this. And so what happens is the 2 comes down, x squared plus 4x plus 4, that basically now is x plus 2. And how do I know that? Because when we did 4 divided by 2, that was the value of 2. So 2 squared was 4. So that's where we get the 2 here. So x plus 2 squared, okay? And then when I go here, 5 minus, what's 2 times 4? That's 8. 5 minus 8 is -3. So now I have a new way of writing g of x. Exactly the same, however, just a different way of looking at it. So now, when I look at this and I go back to my graph, usually what you do here is you take this term, so x plus 2. You want to kind of zero that term out. So how would I zero out that term? Well, if I have x equals -2, right, that would zero that, -2 plus 2 is 0. 0 squared is 0. 2 times 0 is 0. And what would g of x be? -3. That sounds familiar. So here is the answer. G of x is a minimum, and the minimum value is -3. So what we saw from graphing was it's probably -3. We can now actually prove that using completing the square. And for a little bit of extra, we now know where that minimum occurs on the x-axis, right? It occurs here, which is at -2. So the point here at the minimum would be -2, -3. Thanks for watching.